In this part of the problem, we're going to find the expectation value of the momentum, and we were hinted at doing it the quick way in the problem, the quick way being the product of the mass and the velocity of the particle. In our case, since we have the expectation value of momentum, it's going to be the time derivative of the expectation value position, which we found in the previous part of the problem. So we'll go ahead and write that out in terms of our answer from the previous part here, which is a over 2 minus the quantity of a over 2 times 32 over 9 pi squared sine of 3, oh, it's actually cosine 3 omega t. And immediately we can see that when this time derivative goes into this quantity here, this is just going to turn into a 0. These are just going to be constants here, so constants, and this is going to be negative 3 omega sine of what's in the argument here. So we'll go ahead and write that out, and in terms of after everything, all the algebra happens, we're going to leave it in terms of a over 2 here for reasons that I stated in the previous problem, because it's just always nice to write things in terms of things that you already know. Omega sine of quantity of 3 omega t here. So, and I mean, that's our answer. Nothing really physically enlightening about this here. We can make further substitutions and just do more algebra, since in the problem we were given that we could simplify things in terms of omega and this value here. Although I don't necessarily see the physical significance, I think it's just more physically significant to leave it in terms of a over 2 here. But in general, that's our answer.